Let's talk about recursivity. I would like to solve this question where I receive an object. It's a nested object, so we don't know how deep the object will be, but essentially we just want to figure out which is the maximum value or the biggest value within that object. So there are different ways to solve it. This is a good example of where recursiveness may be useful, right? So in reality, what we need to do, I'm going to try to be brave and I'm going to try to return the value straight away. So I'm going to do object.values. So that will return, for the first case, 2, then an object with C1, D4, right? Let's do the break line. And then let's use reduce. So then we have the maximum value, which is the accumulator, and then we have the current value. Right. So the default value for the accumulator should be 0, because then we want to compare if each value is bigger than max or not, right? So what's next? Let me have a look. Yeah, so the value in that case could be a number or an object. If it's a number, it's easy, right? We can see if 2 is bigger than 0. It's easy. But if it's an object, then where the problem starts, right? So let's see. Let's try to get the current value. So so I'm going to create a new variable, and then I'm going to check type of value. So if it's an object, I'll have to call the same function again, recursively. Well, I'll do that in a minute. If not, let's do the easiest one first. So the new candidate is the value, right? So then reduce will pass to the next iteration. Well, we need to compare max against candidate max, right? So candidate max is bigger than max, then candidate max will be the new max. Otherwise, we'll be just passing the previous value to the next iteration. So then, if the type of value is an object, then we want to call the same function again, passing the value, right? So the first example, a should be 2, so type of value is a number, so it will, yes, candidate max will be 2. Is 2 bigger than 0? Yes, it is. Then the new maximum is 2. On the second iteration, v is an object, so then we'll call get max value again, passing this object c1 and d4. So it will start again. It will create like a new dimension where it will receive c1 and d4. So eventually the max after these 2 iterations of the new dimension will be 4. So finally candidate max will be 4. It was 2 before. So 4 is greater than 2. Then candidate max will win. So the value this function should return is 4. Let's see if it works. Yes, it works, right? So that's pretty much it. I mean, if you struggle with this concept, what we can do it now actually. So something we can do is we can open DevTools, and then we can create a new snippet and play around with it, right? And that's usually the best way just to see what's going on. So yes, I'm going just again to copy the same, right? So I'm trying to replicate the same example using DevTools, because then we could do some debugging. So I got the get max value function. I copied the wrong thing. Right, let's try to copy that. If not, I mean, let's do it just manually, right? It's not a big problem. Right, so yeah, I mean, yeah, I cannot copy that because of a reason, but that's fine. I mean, let's make it up. So we could get max value, and then A, 2, C, V, C, -1, D, 4. Yeah, whatever, right? So yeah, so first of all, let's see if that works. So that should return 4 exactly. So that works now, right? So now let's set the breakpoint on the reduce, because that's the complex part, right? So on the first iteration, we're just getting an array of values. So it will be an array of 2 elements, 2, and this object. So if we play the example, you can see max is 0 because we're initializing it here. Value should be 2. This is very simple, right? So candidate max is still undefined, but then in this line, candidate max is 2, which is greater than 0. So we'll pass 2 as the new max, as you can see here. So now max is 2. And this is the complex part, because now value is an object. So it's not that simple to get the maximum value of that object. But because of that, that's where we're going to do the recursiveness, because we're going to call get max value again. So if I run the, if I resume the script, it will stop again here on this line, but it will be on a new dimension. So max will be 0 and value will be -1. Exactly. You see? Max 0, value -1, right? So then we start again. Is candidate max, well, will be in the middle, right? So candidate max is -1, right? So in that particular case, candidate max is not greater than 0, so it will return 0. Obviously, I mean, this example will fail if all the numbers are negative, right? But in that case, the solution will be as simple as initializing the accumulator to the minimum integer or to the first value on the list, whatever, right? Let's ignore these details. But hey, for now, the maximum will be 0. So on the last iteration of the second dimension, max is 0, value should be 4. So this case is crystal clear. So 4 is bigger than 0. So then if I resume the script, it will stop again, it should stop again on line number 9 of the original iteration. Here we go. You see? So now candidate max should be 4, because this is what the nested iteration returned, right? So then we need to compare 4 against the max, and max should be 2, because that was the maximum value before we went to the nested object, right? And then now the result is very obvious. So 4 is greater than 2, so we'll return 4, and as this is the last iteration, that's it. We got the result, right? So that's pretty much it. I hope that helped.